All right, so this video is going to be about the simplex method with the actual solving steps. So we're going to go through and talk about what each of these steps are and how you identify them and all that kind of fun stuff. So here are the extra pieces that we're adding in today. So the first thing that you're going to have to do is identify something called the pivot column. Okay, so we're going to identify a pivot column and then a pivot row. So essentially what that is it's going to be the one in our matrix. So you know how when you're solving a regular matrix, you try to get like 1, 0, 0, and then 0, 1, 0, and then 0, 0, 1. So you have like the ones in the diagonal. Those are called pivots. We're going to have pivots for these matrices as well, but they're not necessarily always going to be on that diagonal. So that's our first step is we have to figure out where our pivots are going to be. So the first thing that you're going to do is you are going to find the correct column that you're going to be using. Okay. And in order to do that, you are going to look for the most negative element or entry in the bottom row. Okay. So the most negative entry in the bottom row. We're going to talk about why that is in just a second. All right, but as an example with this guy right here, we look at this bottom row here, and this negative 36 is the most negative element here. So that means that we're going to identify this as our pivot column. All right, so now we have our column here. So the next thing that we have to do is identify the pivot element. So are we going to try to make this R1 or are we going to try to make this R1? Okay, so how you're going to do that is you find the quotient of the solution of each row and its entry in that pivot column. Okay, so for this particular example, these are the solutions for the row. Okay, and we're going to find the quotient. So we're going to divide the solution by the entry in that column. So for this top row, it's going to be 14 divided by 2 because that's the number that's in that pivot column. So 14 divided by 2 is 7. And then for this one, we're going to do 36 divided by 4 because that's the number in its column, which is 9. Okay, so you find these quotients, and then from there, it's the smallest. So the smallest quotient is your pivot element. Okay, so in that case, it's this 7 here is the smaller of the two. So this is going to be our pivot. That's the one that we're going to use as our like 1 to clear out the rest of that column. Okay, once we figure that out, we are then going to go from there to zero out the rest of the column, just like you would with a matrix. So we're going to use this 2 right here to get rid of the 4 and the 36. Okay, and when we're doing that for these guys, we're actually going to use a website. So there's this nifty little website that's going to help you with some of the calculations. You're still going to have to identify all of the steps and all of the row operations, but it will do the actual calculating for you, which will make it a little bit easier. All right, and then for what we're going to do from there is once we finish this one, we're going to then take a look at the bottom again and look for, okay, what's the next most negative entry, then find our pivot element, and then solve from there. Okay, great. So we sort of started this problem, but I actually don't want to finish this one right now. I want to jump to the word problem on the next page. Okay, and the reason for that is that I think it's going to make it a lot more clear to you. Like if you're thinking to yourself, why the heck is it the one, like why do you use the most negative number and why do these quotient matters and why do you want the smallest one? So those were the questions that I was asking when I looked at this method for the first time. So that's why I want to look at this word problem is by looking at this word problem, I think those answers are going to be a lot more clear. So we got the situation where Nikki has 2 part-time jobs. She doesn't want to work more than 12 hours a week. She's determined that for every hour she works at job 1, she needs 2 hours of prep time. So whatever she's doing, she has to prepare for that job ahead of time. So it's going to take a lot of extra time on her part. For the other job, every hour that she works, she needs 1 hour of prep time. So job 2, right, she's got less prep time that she has to work for. She can't spend more than 16 hours prepping. She makes $40 an hour at one job and $30 an hour at the other. How many hours should she work at each job in order to maximize her income? Okay, so we're going to take this a piece at a time, right? First thing that we need to do is define our variables. So the question is asking us how many hours she should work at each job. So I'm going to use X and Y. So X is going to be the number of hours worked at job 1, and Y will be the number of hours worked at job 2. All right, so we got our variables. So next I'm going to write the equation that we're trying to maximize, right? So we've got our objective functions and we've got our constraint functions. I'm going to write my objective function now. Okay, so we want to maximize income. So I'm going to write an equation for Z, which is going to be the income, right, that we're trying to maximize. So what do we know about incomes here? Well, we know that she makes $40 an hour at one job and $30 an hour at the other job. So she gets $40 per hour at job X plus $30 per hour at job Y. Okay, and then just like we did before, I'm just going to take this equation and I'm going to rewrite it. So I'm going to take these guys and move them both over to that side. So negative 40, x minus 30y plus z equals 0. All right, so we have our objective function. Now we need our constraint functions. So what are our constraints? Well, she never wants to work more than 12 hours a week. That's the first constraint. So the number of hours she works here plus the number of hours she works here can't be more than 12. So my first equation is that x plus y has to be less than or equal to 12. The total number of hours she works less than or equal to 12 hours. Okay, our next constraint equation. Well, what else do we know about? Well, they told us some about the preparation time, right? So she needs 2 hours of prep time for the first job, and then she needs 1 hour of prep time for the other job, right? So she's going to need 2 hours per hour worked at the first place, plus 1 hour per hour worked at the second place, and she can't spend more than 16 hours prepping, so that needs to be less than or equal to 16. Okay, and then like usual, we also have those kind of invisible constraints that say that X and Y both have to be greater than or equal to 0, right? You can't work negative hours. So that's also going to be a part of this, but I'm not going to bother to, write that as an inequality. We'll just set that up at the end and say, hey, look, let's double check. Great, they're positive. Okay, so now from here, right, we're going to rewrite these with our slack variables. So I'm going to rewrite this equation using slack variable 1, that when I have x plus y plus whatever that slack variable 1 happens to be, that will make this inequality equal to 12. And my second equation, 2x plus y plus whatever my second slack variable happens to be, makes it equal 16. Okay, so all of this we've done before. We're just setting this up the same way that we've been doing. So now I'm going to go ahead and write my simplex table. So my variables across the top are going to be x, y, my s sub 1, my s sub 2. Those are my two slack variables. Then I'm going to need a z. And then on the other side, you can write c if you want to. You can leave it blank if you want to, but that's going to be what our constant is, just the number part. All right, and then I'm going to fill these lovely numbers into my table. So first equation has 1x and 1y. So 1x, 1y, and 1 slack variable 1. There's no slack 2's or z's, so zeros for those, and that equals 12. Second equation has 2x's and 1y, so 2x's and 1y. No slack variable 1's, but there is a slack variable 2, and there's no z's, and it equals 16. And then down the bottom here, my objective equation. So negative 40x, negative 30y, there's no slack variables, there's 1z, and it equals 0. And there's our simplex table. So that is the stuff that we've been doing. So you should be very comfortable with everything that we've just done. Okay, so now we're going to do this pivot thing, right? So we're trying to figure out what numbers are we going to work off of. So the first thing that you do is you take a look at this bottom row, right? The equation that we're trying to maximize here, right? And we're going to find the most negative number. Okay, so the most negative number in this case is negative 40. So this is going to be the column that we choose to start with. Okay, why are we choosing to start with that column? Well, think about it, right? This equation right here is talking about our profits. Okay, so this is the thing that we want to maximize, how much money she's actually making. Right now, this negative 40, that is dropping our profits by the most, right? We've got negative $40 essentially that we're making right now. So if we can get rid of this negative 40, that's going to have a bigger impact on what our total profit is than dealing with the negative 30. So I'm starting with the most negative value because that's going to have the greatest potential to increase what my profits are. Okay, so that's why I'm selecting this column. So to pick the pivot number, remember you're going to divide this number over here by whatever the number in your pivot column is. So for this first one, I'm going to do 12 divided by 1, which is 12. And the second one, it's 16 divided by 2, which is 8. And we want to pick the smaller number, which in this case would be this guy. So that's going to be my pivot number. Okay, well, why are we choosing that as our pivot number? What on earth is going on here? Why are we dividing these things? And why do you want it to be the smaller one? Okay, well, what that's doing is it's going back to these equations, right? Remember this guy right here, this is just a representation of this inequality. So what are we doing when we do 12 divided by 1? Is we're saying, all right, in our x column, what's the biggest number that x could possibly be, right? When we look at this first equation here, the biggest number that x could possibly be would be 1, right? I'm sorry, 12, not 1, 12, right? Because then y could be 0, and that would be the absolute max that you could get for x. That's what this number is right here. For the second equation, so this guy down here, the biggest number that x could be would be 8, right? Because if there's no y's, then 16 divided by 2 would get you to that 8, right? So 8 is the absolute biggest that x could possibly be. So 12 and 8, those are for each of those equations, the biggest number that you could possibly get for x. Okay, so then why do we want the smaller number? Well, because both of these have restrictions on what x could be. But if this one is saying that x can only be 8 at the absolute most, even though this one allows you to get bigger, we want both of these inequalities to be true, right? So this one's telling me that she can work at most 8 hours at the first job. That's it, as most she can do. So I want to stick with this guy because that's like the tighter restriction, right? That's the more restrictive thing that we're saying here. This guy's going to let you have a little bit more leeway. But like if I end up with an answer that says that I can work 11 hours at job X, that's going to be a problem because it'll make this one true, but not this one. So I want to go with the most restrictive feature here because that's the biggest thing that X can be. That's the most number of hours I can work at that particular job. Okay, so that's why we're selecting this as our pivot number. Okay, now that we have this guy, what we're going to do is we're going to use this and we're going to cancel out both of these, just like we did in our matrices, right? Our goal here is going to be to make this guy a 1 and make these guys into zeros, okay? Now, when you go to do this, you're probably going to end up with a whole bunch of fractions. So to make life a little bit easier, I have this lovely little website that we're going to use. So that is this guy right here. Okay, so what you're going to do with this guy is you're going to start by telling it how big you need your matrix to be. So when we look at this guy right now, we're saying, okay, this is my matrix and sorry, let me flip back over. So how big is it? Well, I have 1, 2, 3, 4, 5, 6 columns and then 1, 2, 3 rows, right? So I need 3 rows and 6 columns. And then I'm going to hit submit. All right, and you'll notice that this looks kind of like the matrix we just had. Okay, so all I'm going to do, I'm not going to put those letters across the top, right? We have the X, Y, S1, S2, Z, C. I'm going to skip that, and then I'm just going to enter all of these numbers into that matrix. Okay, so I'm going to start typing these numbers in. It was 1, and then I'm hitting tab to move to the next one, which is just a little bit faster than clicking. So I'm just entering in those numbers exactly as they are in the Simplex table that we just wrote. And again, I'm hitting the tab button to move between one cell and the other. It just saves me a little bit of time. Okay, so now I'm down to my bottom row where I'm typing in the -40, -30, 0, 0, 1, 0. Okay, and then you're going to click submit. All right, so you'll see up here, here's your table, right? Double check, make sure that you typed it in right. If you didn't, you can just hit the back button and it'll let you go back and edit whatever it needs to be. Okay, so here's our matrix. And then down here, it lets you perform different operations to your matrix. So the top one will let you add a number times some row, first, second, or third row to another row. So this is the like multiply by something and then add it to another row. Interchange is swapping 2 rows. So you can tell it to swap 2 rows. We don't want to do that with this particular problem. So we're not going to do any row swapping. All right, and this bottom one is going to let you multiply a row by a number or divide. When you want to divide a row by a number, you're just going to have to use fractions. Okay, so with this guy, remember we said this 2 right here was going to be our pivot, right? So we're going to go off of that 2. So the first thing I want to do is make that 2 into a 1. Okay, so to do that, I'm going to have to divide this entire row by 2. I don't have an operation that says divide by 2, so instead I'm going to have to multiply it by a half. So I'm going to come down here to multiply. I'm going to say use the second row and multiply it by 1/2. Okay, you could also type in 0.5 and then click do it. Okay, so it took this and multiplied the second row by 1/2. This is my new matrix. Notice that there's some fractions in here. That's why we're using a computer. Okay, so this is my pivot. I'm going to use this to get rid of these 2 numbers here and here. So I want to use this 1 to get rid of the 1 in the top row up here. So how do I do that? Well, I'm going to multiply this row by -1 and then add it to the top row. Okay, so I'm going to add -1 times the second row to the first row. So -1 times the second row, add that to the first row. Okay, I clicked do it, and now I've got my 0 here. Some still fractions, that's okay. All right, and then from here, we're gonna do the same thing with this bottom row. So I'm gonna have to multiply row 2 by +40 and then add it to the bottom row. So I'm gonna add +40 times the second row to the third row and click do it. Okay, so this is the matrix that it was right before I clicked that. Here's my new matrix. All right, so we used our pivot and now we've got zeros elsewhere in that column. So what we're going to do now is we're going to do the same thing again. We're going to go back and find what's my new pivot column and what's my new pivot entry. So I'm going to look around the bottom here and I want the most negative number. So right now, my most negative number is this 10, right? This -10. So this right here is going to be my new pivot column, okay? And then I'm going to use that to figure out my new pivot entries. All right, so I'm going to take just a second and I'm going to copy this down onto my paper just so that we can talk about what we have here. So I'm just copying these numbers down and I'm going to flip my camera over in just a second so you can see what I'm looking at. Again, all I'm doing is just copying this down so I can kind of point to things a little bit easier and you can sort of see what I'm doing. Okay, so here we go. This is my new matrix right here. Okay, so again, what we're looking for, the most negative number in the bottom. So that's this guy, that's my pivot column. And then remember, you want to divide each of your solutions here by the number in that row. So for this one, I'm going to do 4 divided by 1/2. And be careful, that's not 4 times 1/2. 4 times 1/2 would be 2. 4 divided by 1/2 is 8. Okay, and then in the second row, I'm doing 8 divided by 1/2. 8 divided by 1/2 is 16. So I want the more negative number, which means this is going to be my new pivot. Okay, so that's going to be my new pivot. So great. Now we've got our pivot number. I'm going back to this matrix, and now I need to do the same thing here. I need to make this 1/2 here into a 1, and then I'm going to use it to clear out the rest of the column. So how do I make a 1/2 into a 1? Multiply by 2. So I'm going to multiply the top row by 2. Do it. Now I've got my nice 1 here. And I'm going to use that to clear out the rest of this column. So multiply this by -1/2 and add it to row 2. So I'm going to add -1/2 times the first row to the second row. Okay, make sure you're always getting the 0 that you're supposed to be doing. If you screw something up, you can just hit the back button. It'll take you right back to what you did before and you can fix it. You can always go back forward. It saves this. It's a really nice website. It saves things for you. All right, and then I'm going to use this 1 up at the top. Remember, that's our pivot element. And I'm going to multiply by +10 and add it to the bottom row. So I'm going to add +10 times the first row to the third row. Do it. And there's our new matrix. Okay, so again, I'm going to take just a second and copy this down. So I'm just writing this down on my paper so that we'll be able to look at it and kind of talk about it a little bit. Okay, here's my new matrix. So this right here is our solution. How do I know that I'm done? Because now when I go to look for my next column, right, there's no more negative numbers down here. So once you get to a point where there's no negative numbers, that's where you're going to stop. Okay, so no negative numbers, right, in the bottom row, which means that we're going to stop. All right, so from here, we just need to read our solution, right? So remember when I look at these, remember this was X, this is Y, that's slack 1, slack 2, that's Z, and that's our constant, right? So when I take my answers out of this, this is telling me that 1Y equals 8, right? Remember our slack variables don't really count because originally these were inequalities. We made up the slack variables to turn them into equations, but the equations don't actually matter. It's the inequalities that matter. So whatever those slack variables are, I don't even care, right? All I care about is what X and Y are going to be. So my Y value is going to be 8. This one, I've got an X variable, right? With slack variables I don't care about. So just that 1X equals 4. Down here, again, slack variables I don't care about. 1Z equals 400. Okay, make sure you're careful. Notice that these don't go in alphabetical order, right? The Y came first in this case. Sometimes Y will come first, sometimes X will come first. All right, so what does that actually tell me about my problem? Remember, X was job 1, Y was job 2, right? So what this is telling me is that Nikki should work 4 hours at job 1 and 8 hours at job 2, right? And she will make $400. Okay, so she's going to end up making $400 if she works that allotment of hours, and that is the most money that she can make. So we've just maximized her profits here. Okay, and that's what we're looking to do in these particular problems. Okay, so again, you set up your equations, right? Take your inequalities, turn them into equations, set up your simplex table. Find the most negative number in the bottom row, right? Because we're trying to increase our profits, right? That's the number we want to be big. So the thing that's hurting it the most, that's the one we want to deal with first. Okay, and then divide your quotient by whatever this pivot number is. Take the smaller one, right? Because that's the more restrictive thing for what your number of hours can be, right? This one was telling you that the most that X you could work in is 8, and this one told you the most that you could do was 12. Go with the more restrictive option. Okay, use your simplex table once you have those pivots. Use that website to clear out the rest of the columns. So you've just got the 1 and the zeros. Find your new pivot, clear it out. So you just have 1 and zeros. And then from there, when there's no more negative numbers left, you're ready to pull your solution out and then just interpret what that means. Okay, so let's go back to this front page and do just a couple more examples. Okay, so this guy here, we already said our most negative number was negative 36. We divided our two quotients here and found the smaller one was 7. So this is our pivot. So I'm going to go back to this website. All right. And at this point, we need to kind of get back to clear it out. From here, if you wanted to, you can click all operations view to see the row operations performed, and it will walk you through what all your different steps are. So it keeps track of what you did every single time, which is really, really helpful. So as you're kind of looking at these, when you're looking at your tests and quizzes, I'm going to ask you to write out what your steps were, what you did, right? And you should just be able to grab those right from here and write them down for me. I might also ask you to take like a screenshot of this page and send me that. Okay, so I just went back. All right, and what I'm going to do now is I just want to go all the way back to the original thing here. So I'm going to come up here. If you right click on the arrow, it gives you all the different websites that you've been in. I'm just going to go all the way back to the first one. Right, so you could hit the back button a whole bunch of times. It's just a little faster if you right click on it. Okay, so we're going to set up my new matrix. So I am now taking this matrix here, and I'm going to go enter that in. It's the same size as the one we just did, so I'm just going to click submit. And I'm going to go ahead and type all of those numbers in. So it's 1, 2, 1, 0, 0, 0, oops, Sorry, only 2 zeros and then a 14. There we go. Sorry. And then 3, 4, 0, 1, 0, 36. And then the bottom one is 3, 4. Oops, no, it's not. That's the one I just did. My goodness. All right, negative 24, negative 36, 0, 0, 1, 0. All right, so I've entered those numbers in, and now I'm going to click submit. All right, so we have this. We've already decided on what our pivot is, right? Remember, we decided this 2 right here was our pivot. So I want to make that into a 1. So I'm going to multiply the first row by 1/2. Do it. There we go. Now I got my 1. And I'm going to use that to clear out the next 2 rows. So I'm going to multiply this 1 by -4 and add it to row 2. So I'm adding -4 times the first row to the second row. Do it. And then I'm going to do this top row times positive 36 and add that to the bottom one. So I'm going to do 36 times the first row, and I'm going to add that to the third row. Do it. Now I've got my 1, zeros elsewhere. We're good to go. All right. So again, I'm just going to come over. I'm going to copy this down so that I have something to look at. Okay, we will talk about what exactly your expectations are for what your homework is going to look like in class. If you're in my class, if you happen to be a random YouTube stranger, hi. Hopefully this is being helpful for you. Okay, so I copied it down. So here's our lovely thing. So identifying our next column, that's the most negative entry. And then I'm going to find those quotients, right? So this top one is going to be 7 divided by 1/2. Dividing by 1/2 is multiplying by 2, so that's 14. And then this one's going to be 8 divided by 1, which is 8. That's our smaller number. So here's our new pivot, which is conveniently already a 1. So awesome. All right, back to my website. So I'm going to take this 1, and I got to use it to get rid of this 1/2 and the -6. So first move is I'm going to multiply the second row by -1/2. So I'm going to add -1/2 times the second row to the first row. Do it. And then I'm going to do 6 times the middle row, add it to the bottom row. So 6 times the second row, add it to the third row. Do it. All right. And then at this point, I'm all set, right? Because the next thing that I would look for is I'd be looking in that bottom row and trying to see if there were any more negative numbers in the bottom. There aren't any more negative numbers, so I'm all set. I can stop now. We have finished doing this problem. So we've found our solution. We just now have to figure out what our solution actually is. So there's that matrix that we just did. All right, so from here, I'm just going to pull out what my solutions are. So remember, this is x, y, /1, /2, z, and that's our constant. So this top row is telling me that y equals 3. This one's telling me x equals 8. And this one's telling me that z is 300. Okay, so our solution to this problem, we don't have any context to really say what this means, right? But it's saying that when x is 8 and y is 3, z will become 300, and that's your maximum. That's the maximized problem here. All right, cool. One more example. We'll run through this one more time. Okay, so with this one, we've already got all our equations written. Okay, so we're going to start by reworking our objective function. So I want to get it so that all of these are on one side. So I'm going to bring these guys over. That's going to be -2x minus y plus z equals 0. This guy, I'm going to add a slack variable. So it'll be x plus 3y plus my slack variable now makes it equal -12. This guy, when I add my slack variable, 2x plus y plus slack variable 2 now equals 10. And for this particular problem, we actually have a third equation. So I'm going to need a third slack variable, right? I can't use the same slack variables as either of the other two. So this one's going to be x plus y plus slack variable 3 equals 4. These guys, again, we don't need to bother with these ones, right? Those are very, very common restrictions that x and y have to be positive. So that's just kind of a quick check at the end. All right, so now that we have three slack variables, the only thing